Okay, guys, so we are gonna start. So we're going to do the notes for exponential models. This is pretty short. Exponential models, guys, y equals a times b to the x power, and then are the same as f of x equals a to the times b to the x power. Y really means f of x. That is really where what value of y is. Okay, so you can see different way of writing it. We'll talk about notation of functions later on in the future. So what do they mean? The A is the starting point, so where you start. So kind of like a B for linear function, the y-intercept. And that number, that is a number when x is 0, that's where you start. So when time is 0, you're going to have a amount of something, or whatever the number is. B represents the change, and you gotta be careful with that. We'll talk about it in a moment. And that is kind of like a slope in the linear function. And x represents time, and that is we're taking it to the power of x. So for example, I have here 3 times 2 to the x power. So I know this is my starting point. So I would fill my table. This table is too long. It doesn't need that many. If I would make my table, I would put 0 in the middle. So 1, 2, 3, 4, 5. So 0 would go on the third one. So at starting point, when time is 0, or x is 0, the y value is 3. That's what I know from the formula. Okay, I will go 1 down, 1 up, 1 up. Okay. Now, there's 2 ways of finding the y values here. You can either use your formula, y equals 3 times 2 to negative second power, because now x is negative 2. And we can put it in the calculator. If I find my calculator, here it is. So I'm going to put it in the calculator. Sorry. So I'm going to put 3 times 2. This is the power 1. Any power if you want to use to the power negative 2. Okay. 0.75. That's one way of doing this, by just plugging in x, and that's how you're going to come out with y. Now, for exponential function, also there's another way, and it's a little bit easier. So, for example, if I know the starting point is 3, and I know my change is 2, right? Linear function, they go up by some number by adding or subtracting if you're going down. Exponential, they go by multiplication. So if I want to go 1 up, they have to be by 1 unit though. Okay, so they cannot be like 0 to 5, because that's not going to work. They're going to go every 1 unit up or every 1 unit down. I can just multiply my y value by 2, because my change is 2. So my new value when x is 1, it's going to be 6. And then I go again when x is 2. Again, I multiply by the same change, because change is 2 for us. 6 times 2 is 12. And I can do the same thing going backwards. But this time I won't multiply, I'm going to divide, because I'm going in the negative direction. I'm going to divide by 2. So 3 divided by 2 is 1.5. And then 1.5 divided by 2 will give me 0.75. So whichever way you prefer, you can use um, any of those. Now, graphing it, well, I'm just plotting the points. For 0, I know it's 3. For 1 is 6. For 2, it doesn't even show 12, but I know 12 is somewhere here, right? And then negative direction. For negative 1, it's going to be a 1.5. And then negative 2 is 7.75. So it's got really, really close to 0. Now, your function will never cross it. unless we're going to move it around, because I'm going to get closer, the number is going to get closer and closer to zero. They're going to be smaller and smaller and smaller, but I will never end up with something equals to zero, because if I keep dividing numbers by 2, by 2, by 2, by 2, they're just going to get really, really small. So we're not crossing the x-axis here. Okay, this problem, I don't think we're ready for this problem, and I don't think we need to at this moment, so we can cross it off. The only one we have is this one. So we're going to do a lot of word problems for this unit, for this section, not as many as graphing. So we have a population in Greensville is increasing at the rate 5.6% per year. If it tells you percent per year, any percent increase, that usually means we're talking about exponential growth, and that is the change. That's how they change, right? And again, guys, I told you be careful with this because we need to do one extra step with that, but that's in a moment. And then the population today is 8,000 people. So that is my start. I'm starting today. That's where it's 8,000 people. That's a really small place. Now the question is, what will it be in 10 years? So 10 years, that is representing time. So if I go back to, I'm going to use this space. This was my formula. Okay. That was the beginning. That was the change. And that was the time, right? So with the change, guys, you have to do extra step. So first, you want to take the percent and change it into decimal. How do we change it into decimal? Well, we divide the percent by 100, right? That's the first step. And be careful with this, because 5.6% is not 0.56, it's 0.056, okay? That's the first step. The second step, we need to add 1. So it's 1 plus 0.056, which is 1.056. And that actually is my change. That is the B that I'm going to use. I cannot use the percentage here. I have to change it a little bit to get to actual change. So my formula for this problem that I'm going to use, it will be 8,000, because that's my start, times 1.056 to the power of x. That's just the formula that I'm going to use and substitute whatever I need to. Now, why are we using 1 here? Why are we adding 1? Well, this will, if you multiply this 1 after taking a power, that will take into consideration already that 8,000 they were there before. Okay, so we're not only finding the change, we're finding the total amount of people after the time. So that one basically takes care of the people that are already there. That's why we're using it. So now what's the question? Well, the question is really how many people we're going to have after 10 years. And we know that time is 10 and x is representing by time. So I'm putting it just to my formula. And I'm using my calculator. And I'm going to use 8,000 times 1.056 to the power of 10. And when I press enter, it will give me the answer. Now we got to think about it a little bit, because my answer is 13,795.23. Now we're talking about population. Usually we don't have people being born as 0.23 person. So if they're talking about numbers, not like in millions, that will be okay. But if it's just 8,000, we cannot have 0.23 of the person. So we don't count this. So you have to think about the answer if it makes sense to your problem. So after 10 years, I'm going to end up with 13,795 people in this city if the rate of change will stay the same. So that was about exponential models here.